dy dx of y is equals to x raised to the power of 3. So now, to find dy dx now, you know that you are going to differentiate y with respect to x. Okay, now the problem now is that you are given x to the raised to the power of another x. So how will you obtain the solution for that? So that's what I'm going to teach you in this tutorial. Okay, it's very simple to solve something like that. Okay, now let's start. We have y is equals to x raised to the power of x. Okay, now don't forget from the standard differentiation, when you have y to be x raised to the power n, we said dy dx for this should be what? Ns raised to the power of what? N minus 1. Okay, can you use the same method to solve this? No. Why? Because the power of x here, which happens to be n, is what? Is constant. Do you get that? And the x you have here is what? Independent variable. So there is no way you can make use of this approach to solve this. Okay, now to solve any kind of this, so you have to find a way to bring this x where it's at power to what? To base. So that's the first thing you have to do. So to do that now, you introduce logarithm to both sides. That is natural log, which happens to be what? Ln. So when you introduce ln to both sides, you have ln y to be what? Ln x raised to the power of x. And don't forget from the rule of ln, so when you have something like this, you can write that to be x ln x. Okay, I'm sure you are getting that. Now we want to differentiate ln y with respect to x. So this is when you differentiate ln y, you have 1 over y, then you have dy dx. And the next thing now, to differentiate x ln x, now what do you have to do? You make use of what? Product rule. So you differentiate the first one, you leave the other one as constant, while you differentiate the second one and leave the first one as what? As constant. Now when you differentiate the first one you have here, which is x, you have what? 1 multiplied by, we are keeping ln x as constant now. Then plus, this time around you have to keep x as constant and differentiate ln x. So when you differentiate ln x, you have what? 1 over x. Okay, now from this side you have 1 over y dy dx is equals to 1 multiplied by ln x, that will give you ln x. X multiplied by 1 over x, that will give you 1. Don't forget, what do you have to find? You have to find dy dx. So to get dy dx now, that means you have to eliminate 1 over y. So how will you eliminate that? You can multiply both sides by y. So when you multiply this side by y, you multiply everything here by y. So obviously this y will cancel this y. Then you left with what? Dy dx. To be y, then ln x plus 1. Okay, now can you leave your answer like this? No, absolutely no. Why? Because you cannot leave your answer to be in terms of what? In terms of y. So you have to make substitution for y, which happens to be what? X raised to the power of x. Okay, when you make substitution for that, you have dy dx now to be what? X raised to the power x, then ln x plus 1. So when you differentiate x raised to the power of x, so this is what you are going to have, and that is the derivative of that. Okay, thanks so much guys for watching. Don't forget to like, comment and share. So if you are watching our YouTube channel for the first time, don't forget to subscribe. Thank you so much guys.